Hey everyone, and welcome to this explainer. Today we are going to look at the ultimate invisible conductor, the one that controls the entire orchestra of nature. I'm talking about light. Now, you might just think of light as the thing that helps us see where we're going, but it's actually so much more than that. It literally runs the incredible, hidden clockwork of the natural world all around us. Have you ever wondered about this mystery? How do bears know exactly when it's time to retreat into their caves and prepare for winter? I mean, it's not like they have a calendar hanging on the wall of their den, right? Well, the answer to this puzzle isn't a date on a piece of paper, but something you and I see every single day, often without even realizing its power. So here is our roadmap for today. First, we'll cover why organisms need light. Second, understanding the photoperiod. Third, photoperiodism and the seasons. Fourth, animal reactions to light. And finally, plant ecological light groups. All right, section 1. Why organisms need light. At its core, light equals survival.
Okay, let's dive right into this with the vital process of photosynthesis. Plants are just absolutely incredible because they magically take water from the soil, carbon dioxide from the air, and light from the sun, and they use all of that to make their own food. And in doing this, they release oxygen, which is exactly what we need to breathe. Without light, this whole life-giving system simply stops dead in its tracks.
But hey, it's not just plants. Animals rely on light just as much, mostly to navigate their daily lives. It helps them find their way, locate food, avoid danger, and just generally know what time of day it is. Think about bees, for example. They use the sunlight during the day to hunt down blooming flowers for nectar. At the very same time, a deer is using that daylight to carefully spot and avoid any predators that might be hiding in the woods. Moving on to section 2, understanding the photoperiod and how organisms actually measure the seasons. So, how exactly do organisms measure light? Well, it all starts with the photoperiod. The photoperiod is simply the length of the light and dark periods in a single 24-hour day. Think of it like nature's daily, continuous 24-hour clock, one that just never stops ticking. Now, think about the difference between our seasons. In the summer, we get these great, long days with hours and hours of sunlight. But in the winter, we have much longer nights and darker, shorter days. Organisms can beautifully measure these exact differences in day length. They sense the changing light, and that tells them exactly what they need to do to survive the incoming weather. Which brings us to section 3, photoperiodism and the seasons, essentially nature's calendar. So, the absolutely crucial point here is understanding this next scientific term, photoperiodism. This is the reaction of organisms to those changes in the length of day and night. It's the incredible, almost magical way that living things automatically adapt as the seasons change. When the days get shorter or longer, plants automatically react. This shift in the photoperiod is what triggers the beautiful flowering of plants in the spring. And it's what causes the ripening of fruit, like apples, later on in the year. Ever wonder how a maple tree knows it's time to drop its leaves? It literally feels the days getting shorter as autumn approaches. All right, section 4, animal reactions to light and their seasonal behavior shifts. And here is the answer to our mystery about the bear. The shorter days in autumn act as a massive natural alarm clock, triggering major seasonal behavior changes. That shrinking daylight tells the bear and the hedgehog that it is time for winter hibernation. This same shift in daylight triggers bird migration, too. It's a critical, life-saving tool that tells birds like geese and swallows to pack up and fly to warmer places. It even causes molting, signaling animals like the hare and the squirrel to completely change their fur color and thickness to prep for the winter snow. And finally, section 5, plant ecological light groups. Basically, plant light diets. You know, just like people have their favorite foods, plants have specific light requirements to survive. We can actually break down the ecological groups of plants into 3 main types based on this. First, light-loving plants. Second, shade-loving plants. And third, shade-tolerant plants. Let's look at what each group needs to really thrive. First up, we have our light-loving plants. These guys need bright sunlight, and they absolutely do not grow well in the shade. They usually have smaller leaves, they easily tolerate the intense heat of the strong sun, and they grow super quickly in wide-open places like meadows. Great examples of this are the pine tree and the sunflower. I mean, the sunflower is so light-loving that it literally turns its head throughout the day to directly face the sun. On the flip side, let's contrast that with shade-loving plants. These plants grow really well in low light and actually cannot handle bright sun at all. Because of this, they often have large, thin leaves to catch whatever tiny amount of light they can possibly find, and they grow much slower. The moss and the fern are perfect examples here. You'll find them living very happily on the dark, damp forest floor, right under the thick canopy of larger trees. And this brilliantly illustrates our third group, shade-tolerant plants. These are nature's highly adaptable survivalists. They can grow perfectly fine in bright light, but they can also comfortably survive in the shade. Because they're so flexible with different light conditions, they can live in a ton of various habitats. The maple tree and the spruce are excellent examples of plants that fall right into this adaptable group.
So, what does this all mean? What you should really take away from this explainer is that light is truly the ultimate invisible conductor of nature. Understanding the photoperiod helps us see how every single plant and animal is perfectly, seamlessly synced to the rhythm of our planet. From a flower bursting into bloom all the way to a bear settling down for a long winter nap, light is quietly pulling all the strings.
I want to leave you with a final thought today. Now that you understand exactly how this natural clock works, I really encourage you to step outside. Watch the birds, look closely at the leaves on a maple tree, and observe these amazing seasonal behavior changes for yourself. But above all, remember this message. Study nature. Understand its laws. Protect it. So the next time you step outside, I want you to ask yourself, what secret signals is the sunlight sending to the nature in your own backyard right this very second?